It's the most pressure-packed shot in golf. Whether it's a 30-foot roller or a 6-inch tap-in, draining an important putt can be the difference between victory and defeat.
Well, when I get over a putt, I really just try to trust my instinct and trust what I've done during practice. So when you finally get over a putt and it really matters, you just try to let the body go.
Suzanne Pedersen is a professional golfer on the LPGA Tour. As of 2012, she has won more than 10 tournaments and has had more than 70 top 10 finishes.
In putting, it's pretty much what your eyes sees, and then the signals the eyes gives your body and nerves, and then it finally translates out in the club.
More than just a psychological exercise, putting is an excellent way to demonstrate the physics concepts of work, energy, and power.
Bring it back a little bit so she can see her putt.
Am I going to try and look after the ball?
To illustrate these concepts, we filmed Pedersen and other golfers putting with a Phantom camera, a high-speed digital camera that has the ability to shoot at up to 10,000 frames per second.
Perfect, got it. 2K, 240.
The first concept is energy, which is what the golfer uses to move the ball.
So the club starts with potential energy, and during impact the club slows down, loses some of its kinetic energy during contact. The ball gains that kinetic energy and the two bodies separate and the ball leaves with kinetic energy.
There are two types of energy, and both are at play during the putt. There is potential energy or stored energy, which in this case is gravitational potential energy, and kinetic energy, which occurs when an object is moving.
You're transferring energy from the putter head to the golf ball, and as the club comes in and hits the golf ball, there's a period of time when they're together, very, very short period of time.
When the putter and the ball are moving together, some of the kinetic energy is actually stored in the slightly compressed ball as elastic potential energy.
And then the golf ball and golf club proceed together, and then the golf ball goes away, but the club head stays behind. It slows down because you've transferred some of the energy that was in the golf club head as it's coming to hit the ball to the golf ball, and that's what's allowing the golf ball to go forward.
Though some of the kinetic energy remains in the putter even after impact, not all the energy that comes from the putter ends up moving the ball. According to the law of conservation of energy, energy can be neither created nor destroyed, but it can be converted into different forms, such as heat caused by friction, vibrations in the club shaft, and even sound waves.
There's going to be some energy that's lost to the sound that it makes, the little tap that you hear when you hit it, but all in all, the total amount of energy would be conserved.
The second concept is work, or the action of applying force to an object through a distance.
The putter is applying a force to the ball, and the putter and the ball are actually in contact for a significant portion of time, where the putter is applying a force to the ball, moving the ball for a displacement.
In order to calculate the amount of work that the golfer is doing during the putt, we multiply the force the club is providing by the distance the club is traveling as it collides with the ball. The equation is work equals force times distance. If the putter applies around 105 newtons of force to the ball, and the distance when the ball and the putter are in contact is approximately 1 millimeter, then according to the calculation, there is 90 millijoules of work being done. It's also the same amount of kinetic energy that is gained by the ball and lost by the club. And where there's work, there's also power, the final concept. Power is defined as the amount of work completed over a period of time.
If I were to take a box that weighed 100 pounds and I was to push it a foot, and it took me 15 minutes to do that, that's not a lot of power. But if I went behind that box, 100 pounds, and I pushed it a foot and I did it real quickly in a split second, there's a lot of power that goes involved with that.
Power is the rate at which work is done. To figure out how much power is used to accelerate a ball from 0 to 2 meters per second, we use the equation power equals work over time. So the amount of work being completed, 90 millijoules, must be divided by the time it takes to complete the work, or the moment the putter hits the ball, around 1 millisecond. The answer is 103 watts. If someone has a slower putt, they would be applying less power.
They may be applying the same amount of work, but they're doing it at a different rate.
When Suzanne Pedersen is lining up her shot on the green, she may not be thinking of work, energy, and power.
You can put a good roll to the ball, you can put it on a good line, but once that ball kind of disappears off the club face, it's out of your control.
But these physics concepts are at the core of every putt in golf.